right.
Is that Kent's screen? Yeah.
What's that?
So you're sharing your screen, Kent?
Yeah, I'm not going to be very helpful. I don't even understand what's going on in the chat.
Well, so that's, I think maybe that's going to be a common theme tonight.
What's that?
Well, I vote we plow through and we'll kind of learn as we go. Maybe one of us will get something the other doesn't. I don't know.
Yeah, we can learn together.
There we go. Okay, so here on the preparation assignment, part 1, number 1, it says, what are the 5 assumptions to check in order to do inference for simple linear regression? How do you check them? And answer these questions by filling in the chart. So basically that's just the chart from the notes. Okay, and that, so. Okay. Someone take number 2?
Sure. In the formula, y equals beta 0 plus beta 1 x plus e. How do we say that? Is it e? State which each symbol stands for. It's not worded very well, but so b0 beta 0 is the y-intercept, b1 is the slope, and e is the error term.
Okay. And now we're to part 2.
What do we call the error term again, guys?
I don't know what it's called.
Epsilon, is that the one?
Is it epsilon?
That's what it is.
Little epsilon.
Alright, cool.
Epsilon. Okay, blah, blah. We need to use the crocodile thing.
Alright, so crocodile. Okay, check the 5 assumptions for conducting linear regression on the data. List 5 assumptions below and explain how you check the assumptions. Include charts, graphs where appropriate.
Okay. So, did we decide is head length X and body length Y?
Head is X and tail is Y, right?
That's what I thought. Last time we got confused, and I think we did it backwards. So I think that's correct.
The head length is X, correct?
Yeah. I mean, that's how they've been doing it for all the crocodile questions.
Okay.
So looking at the graph, I mean, it's pretty much a linear equation, so that might be one of the things that we can add to the homework assignment.
Agreed.
Yeah. So there's a linear relationship.
Yeah. So there's a linear relationship, and let's see, what are the other requirements? Let's see.
They're hot dog shape or close together.
Distributed.
They are close together. Okay, do you guys know how to make a residual plot of the...
Yeah, I can make that quick. So I'm just highlighting just the fields that have a residual. When you guys put this data in, half of my fields have residuals and half of them don't. Is that normal?
I don't know, I haven't done that really.
Well, when you guys
No,
plug the data into linear regression, what do you get for residuals?
on which ones, Kent?
Well, you guys have plugged in the crocodile data, right?
Yeah.
Uh-huh.
So when you look at your table, explanatory variables and residuals, does it look like my screen?
As of
No.
right now, yes, but it's not cut off. Yours looks like it's halfway cut off on the residual.
Mine goes all the way to 20 on all of them, all the columns. I have all the
Yeah, mine as well.
I'm gonna get a new document then, because I don't trust that now.
Yeah, mine goes to 20 as well.
Yeah, that was really messing me up for slowing me down during the chapter reading because I was plugging everything in and it wasn't matching what they were showing. So I'll fix that.
So is this one where we have to swap the X and the Y? No, these come out the right way. Head and body.
Where do I get those spreadsheets?
If you go into the homework, they should be in there in blue.
Yeah.
They're all throughout the chapter.
And you can go, go to the
No.
text. There's a download page for all of them too.
Well then, how do we...
So we just copy all the residuals and paste that into a QQ.
Okay.
Paste special.
So,
Mine are all spread out everywhere.
Which one did you plug it into? Which QQ plot?
I just plugged it into the regular QQ plot on the quantitative descriptive statistics.
Are you
spread.
plugging just the residuals in?
Yeah, just the residuals.
Okay.
Yeah, the residuals are all over the place. Oh, do I have to sort? I probably have to sort them first. Hold on. Oh, yep, now they're in a line. I lied. They're in a nice, neat line.
wait, what did you do, Dan? You sorted them?
Yeah, so I pasted them originally in the order that they came in from the other spreadsheet, but then as soon as you sort them, they align perfectly. I mean, not perfectly, but darn close.
Okay. When we make the QQ plot, it's pretty close to linear, yeah. Oh, Ken's computer's having issues again, I guess.
So we have to do
So what about
scatter.
Yeah.
So how are you sorting them?
Just select all the values, but just the values, and then go up to, I think it's data at the top, and then sort. And then just take whatever default value they have there. It should work.
Sorry, guys.
No problem. So I'm trying to figure out how to do the graph for C, the variance of the error terms. It's this residual scatter plot.
Yeah, mine's just saying hashtag reference, exclamation point.
Oh, so you want to go to paste special and select values only.
And where is that found at? Paste special?
It should be under edit.
Okay, I see.
Correct.
Right. I'm still not getting a good residual scatter plot. I don't know what I'm doing wrong.
So are you guys trying to make a scatter plot?
I am, yeah.
All you do is you highlight C through E all the way down from 4 through 20. So you just highlight the explanatory and residual values.
Mm-hmm.
And then you click up top on Insert, and then you'll see some chart types, and you'll see one that looks like a scatter plot. It says Insert Scatter X, Y, or Bubble Chart. If you hover over it. I'm in 2016, so it might be a little bit different.
Yeah, it's slightly different on mine, but yeah, it's essentially the same concept.
And then you just choose Scatter, and it's just going to overlay the chart over top of your data, but you can look at it and then just hit go back to get rid of the chart and get it back to your normal.
So when I do that, the residuals do not look like the residuals that they have in the answer key at all.
Well, what do yours look like? I mean, mine are kind of all over the place.
Yeah, mine don't either.
Mine sort of look like they're kind of arranged in a rhombus shape. About 52 is the center, and then there's like a scoop cutout around 40 on the one side.
I'm going to look at the answer key. I think that's what. I think you just described what mine look like.
Answer
key shows something different. Or?
Yeah.
So wait,
different.
you're highlighting the X values and the residuals, right?
Mm-hmm.
Okay. Yeah. But that's fairly closer. Okay, so.
Okay, I'm still having a problem on sorting it from the least to the greatest.
Okay. So, so did you get them pasted in? Okay.
Yeah.
Okay. So just only highlight the data values that you're interested in.
Uh-huh.
And then if you go up to data, the data menu at the top,
Mm-hmm.
and then go down to sort.
And just click that one that says A to Z sort.
Yep, A to Z.
Now it brings up a box that says sort, add levels to sort by column, sort on values, order smallest to largest.
Yeah, values.
Yeah, when I click that, it still is. Wait, okay, that works.
Did it? Okay, good.
Thanks.
I'm glad. No problem.
So what is this supposed to tell us?
So the residuals are supposed to show either that there's a correlation between x and y for well, not x and y, but x and the residuals, or the residuals are sort of randomized. So I think we're hoping that the residuals are randomized based on x, that there's no relationship. But mine does kind of look like that. However, it doesn't look like the answer key at all.
Yeah.
Although the answer key only goes up to 17 on their graph. So I wonder...
Yeah.
No, but their values are negative, where mine are not even... Yeah, no. Mine's off.
Mine does not look like that, but... Yeah, and then the answer key says that observations are independent, and to assume that y's are independent.
Mm-hmm.
Okay. So we're doing exactly that.
And what is the graph, the residual graph?
So the residual graph, you just take the explanatory variable x and all the residuals that are next to it in that second set of columns, and you just make a graph out of that.
Is there a particular graph that we need to make, or?
A scatter plot.
Okay.
But it just doesn't look right to me.
Alright.
What are you guys working on right now?
Hey, Rhett. We're working on trying to get the residual scatter plot to look right.
Okay. So you're just still on prep?
Yeah.
Cool.
So we've got the answer key, and we know what that looks like, but we can't get our stuff to match it.
Gotcha.
I don't think I'm getting the right. Are you guys on to number 2 and stuff?
Number
No,
what?
make my graph look like the other one.
Mm.
Is Kent still on, or is this computer still messing up?
It looks like it just popped right back on.
Oh, okay.
you guys hear me, by the way?
Yes, we can.
Okay, good.
So have you been following us, Kent, our quest for the good residual plot?
Sorry, I've been disconnected for probably the past 5 minutes as I've been
Okay.
having some issues.
Yeah, I still can't get mine to look like the answer key either. Whoa.
So what are we looking at? The answer key shows a plot?
Yeah, it shows a plot for part C that is different than what we get when we put the data in the spreadsheet.
I don't see the plot. Are they showing the plot in the answer key, or they're describing it?
They are showing it.
Huh. Why don't I see that?
I don't know.
The preparation assignment answer key, right?
Yes. Under the variance of the error terms is constant for all values of x minus, or x. Yes, there is no megaphone shape.
Let me load it in Word instead of my phone. Now I see. So we're on C.
Yes. So what are you guys trying? What are your different approaches?
My graph just looks like it doesn't start closer to 0, like it's further spread towards the 30. I don't know if anyone else's looks like that.
Yeah, that's kind of how mine looks too.
Let's see.
Does yours look like it has like a crescent shape where it starts?
Here's mine right here.
Yeah, that's that crescent shape.
But the other one is closer to 0, so I'm trying to figure out why.
Yeah, that's me too.
Rhett and Kent, what are you guys coming up with?
I'm getting what everyone else is getting, and that's, I'm following the directions of the lesson. Right? It says once you've already entered in the explanatory variables in the correct columns, we're given a column of residuals in column E. Highlight both column D and E, explanatory variable and residuals. Click on the Insert tab, and then click on Scatter. The first choice is Scatter with only markers, so select the scatter plot choice. And that's exactly what we're all doing, and it looks like we're all getting the same thing. So is this answer key wrong again, or?
It's possible.
Plus, their scatter plots look like, I guess they could have been done in Excel, just maybe an older version.
Possibly. All right, so do we just want to call it we have it better than they do?
Well, I don't know. Well, how can they possibly have something close to 0? I mean, look at the data. What's close to 0?
No, no idea.
I mean, unless we're going to flip our head and our body length, like we've had to do in the past. Have we tried that yet?
That would be even farther away.
Okay.
Yeah.
Right?
Yeah.
Well, yeah, because then we'd have negative x values, and or no.
Well, you'd have
it'd be even farther away. I see what you're saying. Yeah.
for your x anyway. So I'm just thinking that maybe there's some sort of like an offset that needs to be factored in that pulls everything closer to 0. Because it looks like on their plot, it looks like everything starts at 0.
Yeah, I don't think we're wrong, and it doesn't look like on the quiz that this will be an issue. So
Okay, good.
Well, I vote we move on then. Not get
Sounds
hung
good.
up on the plot. So let's go on to Q. So test the linear relationship, state the null and alternative.
So there is a linear relationship. So our null hypothesis is that, well, they're saying b1 equals 0.
And then not equal 0.
So that's the slope. Right. The slope equals 0. So that they're saying then that the head size does not affect the body size, and our assumption is that it does somehow affect the body size. That's our alternative hypothesis. B is not equal to 0, or B1 is not equal to 0.
So that also becomes 5, and then the test statistic and the value of the test statistic. So
That should be in our sheet. Yep. T for B0, or T for B1, sorry, is 22.675.
wait,
Values really small.
It's in the spreadsheet.
okay. And then the p-value is p-value 1.0.
Ooh, yeah.
1, 14, blah, blah, blah. Yeah,
So we reject the null.
1.0005 something. Yeah, so reject the null. And so we have sufficient evidence to prove there's a linear relationship. Reject.
Yep.
Got a 98% confidence interval for the true slope of the regression. Blah,
So
blah.
make sure we have 0.95 there, right? And our confidence interval for B1 is, see, mine's not the same as what they have on the key either. It's 6.704 and 8.096.
That's what I was going to say. Well, that's
Yeah.
weird. Everything else is the same.
Mm-hmm.
So that's really good.
Yeah, mine
What
is
is
slightly
it?
different, but
What?
I'm getting what you guys are getting at least. So I think
Brenton, Rhett, what'd you guys get on that?
Yeah, I'm getting what you guys are getting.
You guys
Okay.
got
704.
6.704?
What?
You guys got 6.704?
Correct.
Yeah.
I have, yeah.
Yeah, that's what it's saying on mine as well.
Okay.
Yeah. I guess I'll just, that's so weird. I don't know how to, and when we have all the correct information, and that's so weird that, like, the test statistic is the same, and so is the p-value. Confidence interval is not?
Yeah. I think we should all get an automatic A in this class.
Amen. A for effort.
Yeah.
And basic understanding, right?
Right?
Well, should we try the quiz?
Yeah, let's get on it.
Let's do it. I need to go to bed. I'm a grandma. Go to bed at 10.
Alright, so that's good. That's good. Oh man, 15. Alright. So, the linear regression equation is y equals b0 plus b1x, where b0 and b1 are unknown. What are the null and alternative hypotheses for b1? That would be that the null is that b1 or beta 1 equals 0, and that the alternative is that beta 1 is not equal to 0, right?
Right, if it's linear, yeah. A residual is the difference between the observed y and the predicted regression line. That one, right?
Yeah.
Okay.
Yeah.
A plot of residuals supports using linear regression when.
Well, what was? I'm sorry, I'm just catching up now. Question 4: a residual is
It's
the
the difference between the y,
the
yeah.
value, and the value predicted by the regression line.
Yes.
Mm-hmm.
So a plot of residuals supports using linear regression when.
The results look normally distributed.
I thought it was when the residuals. I guess it. Yeah, I guess so. I thought it was.
Yeah, it's the only one that would make sense. Everything else would not, right?
Yeah.
Wait, which one?
You don't want to see a pattern in the residuals. You don't want to see a megaphone shape, which is a pattern in the residuals, and the
Right.
residuals don't necessarily always be positive. So yeah, it has to be the residuals look normally distributed,
Yeah.
which is scattered, right?
Yeah.
And this thing for the next 6 problems.
Math self-efficacy. Our old friend.
Mm-hmm. Alright.
Gender score. Okay. Compute the residuals for the data using software. What statement best describes the residuals?
It forms a linear pattern.
Okay. Cool.
The residuals are all not all negative. There are some positive ones, and they're not between negative 40 and 25.
By the way, how are we pasting this data in, guys? What their confidence is what's affecting their score, not the other way around, obviously, right?
Right.
The confidence is X and score is Y.
Oh, wait. I'll put it in the other way.
Do you guys agree, or?
I thought it was the other way around.
I'm sorry, who was that? Was that Dan?
That's me, Brenton.
Okay. Well, that's how it's in the table, but does their score really affect their confidence, or doesn't their confidence affect their score? What's the response of which? I would have thought the score is what's is responding to their confidence.
Yeah, I think these are reversed.
But I guess maybe we'll get some clues as we go through some of these questions. So are we doing a scatter plot on this? I don't think it matters for the scatter plot. Is that how you guys are looking at this data? For question 6.
Yeah.
Oh no. Well, I'm sorry. For that one, it's just if they're a linear pattern, which it looks to me like they are.
Yeah. So it looks like.
What do you say about the residual?
It looks like that same hand pattern as before because we're using the same data, I think.
Well, now we're supposed to look at the residuals, though, not at the.
Right, and the residuals. What do they look like?
I mean, mine look scattered, which means that they're normally distributed.
Yeah, mine are like almost a circular shape.
Has anybody plugged it into a QQ plot?
Not yet. QQ. Yeah, QQ looks very straight.
Okay. Ready? You're on board with the residuals form a linear pattern for question 6?
I think so. I don't know. It just kind of looks like it's between -40 and 25, but
Between -40 and 25.
I don't know. Just looking at the scatter plot, but
Yeah, it is.
Let's go to the text quick and just see.
Do you guys still have the confidence in the X value and the grade on the test in the Y value?
I put the confidence as X and the grade as the Y.
Okay.
Interesting. Well, yeah, it's almost like that should have been one of the check 2 answers because it is linear. Oh wait, no, it's not linear. It's like the cucumber shape almost. They're spread out a little bit, right?
yeah.
Are we still looking at question 6?
So yeah, I mean, looking at the residuals, they don't form a linear pattern.
Yeah, I guess that's the trick question, right?
Yeah.
I mean, we're looking at residuals, so
Right. So they are between -40 and 25. They don't form a line. The values form a line, but the residuals do not.
okay. Yeah, I agree. So, thank you, Rhett.
Yeah.
Question
And then-
7. Based on the QQ plot to these residuals, what can you say about them? They look fairly normal. Is that what you were saying?
Yeah.
Yeah.
On number 6, we decided they weren't in a linear pattern.
Right. They're not linear, but they are normally distributed.
Yeah, in fact, when you do a scatter plot on the residuals, it's just scattered, which means it's normal, but it doesn't mean that it's a linear pattern. So,
So they're found between 40 and 45.
and then question 7, I think Dan did a QQ plot, says they look good.
Yeah.
Yeah, they look very straight.
Just going to confirm it real quick.
Mm-hmm.
Oh yeah, that looks fantastic.
Right.
That's one of the most beautiful QQs I've ever seen in my life.
Okay, use software to create a scatter plot of the data. Given the scatter plot, residual plot, and the QQ plot, which of the 5 assumptions about linear regressions are satisfied by this data? All that apply. So there is a linear relationship between X and Y. Roughly. It's kind of fuzzy, but yeah. Get the cucumber hot dog shape, I guess. The variance of the error term is constant for all values of X.
Variance of error term is constant for all the
So that was the normal
not,
distribution of residuals.
Yeah, but that's not true because the residuals are all over the place, right? Am I understanding that right?
Oh no, hold on. So normal distribution of residuals is the next one. So the error must be something else.
Variance of error. Let me look it up quick.
Variance of error. Variance of error.
Variance of the error terms is constant.
Constant for all values of X.
A megaphone shape occurs when points tend to be close together on one side of the graph.
Your glass? Yeah.
So the
If
variance.
there's a megaphone shape apparent in the residuals, which I don't think there was, it suggests that the variance of the error terms is not constant for all values of x. It suggests there is a difference in the spread of the residuals. So it's not megaphone shaped.
That sounds pretty good.
So we're checking that the variance of the error terms is constant.
Yeah, I think so. And the x values are measured without error. We have to make the assumption that that's true, correct?
Well, yeah, but look at the question. Is that what it's asking? Given the scatter plot, residual plot, and QQ plot, which of the 5 assumptions about linear regression is satisfied by that data? I don't know if our assumptions are validated by that, is it?
Well, I mean, looking at the data, they do have a decent level of precision with the data, right? I mean, 2 decimal places.
Okay, is that what we're looking? I just didn't know what we're looking for error.
I mean, I don't really know, but they didn't just go, 1, 3, or 5. They went, they kind of got pretty detailed on people's level of confidence. So I'd say that's probably satisfying that constraint.
Okay.
And then the observations are independent. Well, so the x's are not the y. Giving us one y value does not tell us anything about any of the other y values. Is that how we're supposed
right,
to interpret it?
But I would say even the head value, or no, in this case it's not the head value, but the confidence value tells you nothing about their score. They're independently measured, and then the data is kind of brought together to be analyzed.
I see. So they're not, yeah.
So I don't think that one applies.
So I would say that that's true. I just don't know if those last two, if we're measuring that based on the scatter plot, residual plot, and QQ plot. Brenton, what do you think?
I have no idea. I'm confused on the last two. The x values are measured without error, and the observations are independent.
Well, those are 2 things that I thought we were assuming, like based on the homework.
Yeah.
They would just say, like, we have no reason to believe otherwise.
Right.
I don't know. Rhett, what do you think?
I think it's the first 3 are checked, and the last 2 aren't checked.
That's my feeling. I think I'm gonna go with that. I mean, I think this is a tough one. I just like the idea that we're looking at a scatter plot, a residual plot, and a QQ plot for certain things, but it's not for those last 2 things.
I see. Right. No, yeah, you're probably right. Okay, cool. So what is B1?
I'm on a group call, yes.
The estimate for the slope. So the estimate for the slope is 12.680. Is that what you guys got?
I have 12.695.
12.695. Oh, I know what I did. My values are shifted up 1 row. This happens a lot.
So I'm sorry, 12.695. Is that what you guys are getting?
Yeah.
Yeah.
Yes.
Did you get that fixed, Dan?
Yes. 695.
Confidence interval for B1.
674 and then 14.715.
Yes.
Yes, and it actually matches. That's really
nice.
Yeah, right.
Based on evidence and using level of significance 0.05, what conclusion would you make regarding the hypothesis test for B1? So
values are really small, right?
yeah, so we reject no.
You lie.
We can reject it because T is so large. That's, I think, valid. That was in the...
Less than alpha.
But yeah, P value is less than alpha.
Right.
Best one.
Okay, question 12 for hypothesis test for beta 1 slope. If you reject the null hypothesis, what does it mean?
So we have sufficient evidence that
To conclude that the slope of the regression line is not 0.
Yeah, it's not 0.
yeah, because
I got 33 when I did the
Wait.
challenge.
right?
Yeah.
Sufficient evidence, not 0. That's what you guys have?
Mm-hmm.
Isn't that the hypothesis that we start out with? Is the null is that it is 0, and then the alternative is that it is not 0?
Right.
Mm-hmm.
That's just a sound answer.
Yeah. Alright. So use the equestrian, estuary crocodile modified XLS data for the next 3 problems. Head length was used to predict body length, okay? For this data, which variable is the dependent variable? So the dependent variable was the body, because they measured the head
10.
to get the body, right?
10 new animals.
Well, the head is explanatory because if we have the head size, it'll suggest the body size.
Yep, in this case, yeah.
Is that
What
right?
is the...
Wait. So the dependent variable is the body one? I mean the head?
Yeah, because they use the head data to predict the body,
Body length.
so the body has to be dependent on the head.
Okay. Confidence interval.
Oh yeah, so body is dependent.
Mm-hmm. What is the confidence interval for B1 for the crocodile data?
7.6, or wait, what do we look? Oh, confidence. 7.218 and
Hold on.
8.103.
So are you plugging the head length in for X and the body length for Y?
Yes.
Yeah.
Yeah, it's pasted just the way it is in the original sheet.
My data. Okay.
B1 confidence interval.
For the confidence interval, are you guys getting
7.139.
7.218.
Yeah, that's what I got too, and then 8.103.
Ooh, yeah, mine are slightly off.
Sorry, I just heard the trail end of what Stephanie said. What was your answer again, Steph?
7.218 and then 8.103.
Okay, good. That's what I got.
Okay.
Oh, yep, now I have those answers too. Okay.
Based on your confidence interval from the last problem, what can you say about B1?
I would say the first one, at least on mine, since the confidence interval does not contain 0, there is sufficient evidence to conclude that B1 is not equal to 0 because the other ones don't make any sense.
Yeah.
There's a 99% chance the confidence interval will contain the true value of B1.
Yeah.
Doesn't
And we don't even say chance in this class, right?
What's that?
We don't even say chance in this class, right?
Exactly. No, I got in trouble because I said it during office hour.
Dang.
I think I got dropped a letter grade, in fact.
There is insufficient evidence to reject the null hypothesis.
We always think there is sufficient evidence when we reject the null, so that one doesn't work.
Yep. So, yep, I think you're right.
Okay, are we ready to submit?
All right. So, who has the highest grade in the class?
Then not I.
What did you guys get on 10 again?
10,
And
10.674, and 14.715.
Okay, thanks.
No problem.
Well, I'm submitting the quiz, so we'll see how this goes.
Great soul.
Please pass. Please pass.
I'm interested in 8.
We missed number 13, and that's it. So number 13. Why did we miss number 13?
13 we got wrong?
13?
Oh, yeah, weird. That's because no. You guys got it right. I read it wrong.
I put body length. Is that
Telling
right?
you that the head was the independent. I clicked on it while I was talking about it instead of putting the body length of dependent. So yeah, you guys should all be fine. I just was dumb.
Been there before, yeah.
That was the only one, 13?
So not a good idea. Yay.
Yep, everything else is right. Yep, they're all right. Good call, you guys, with the 3 check boxes.
Did anybody else find that the chapter text to be challenging? Way more challenging than the actual quiz and homework?
Yeah.
I feel like the quizzes and homework don't match. Like the quizzes will be easy and like the homework will be really hard. Or like I'll do really well in all the homework and then get really confused on the test. Is that just me?
No, that's not
I
just
feel
you.
like they don't follow the same patterns. But I'm just a really bad tester as well, so I don't know.
No, I think there's something to that because the tests are much more difficult than these things that we do together.
Nice. Yeah, because I feel like sometimes these things are so easy and I'm like, oh, I totally got this. And no, it's not that way on the test.
Right.
I think, do we have more project stuff that's due later this week? I haven't been looking ahead.
Yeah, the PowerPoint.
Okay.
Who's in charge of that? Does anybody know?
I'm in charge of that one.
Okay. So do we want to Google Slides it and everybody can contribute, or?
Are you cool with that? If I can actually just start the Google slide and just share it with everybody. Do you mind working from that, Brenton?
Yeah, that's completely fine. I'm just going to add the previous information that we had in there from the describe the data and everything else.
Okay.
And then maybe put a picture of Kent taking off the shells of all the pistachios for an hour and a half.
I'll have to document some of that, reenact it for you guys, so we'll have some.
Yeah.
But I definitely think little art that you can find online, pistachios and shells lying around, stuff like that, adds a little something to presentations.
Right on.
And then just paste in some data.
Sounds good. Yeah, I'll probably have it done by Friday because I'll be in Utah with the in-laws for conference, so it'll be done by Friday.
Okay, cool. Well, I'll put it up tonight and then share the link with everybody.
All right.
Sounds good.
All right, well, thanks, guys.
All right. Good night.
Have a good night.
Thanks, everybody.
Thanks for the post.
Thanks for hosting, Stephanie.
You're welcome.
All right.